Okay, we're looking at Minitest 26, question 2. Okay, so we've got a block on a rough horizontal surface, and we're given the coefficient of friction. So the fact that it's rough tells us that friction will be involved in our calculations. And then we have a horizontal force that's obviously then making the box move. Okay, so let's sketch all that out. So there's my surface. There's my 3 kilogram box, so the force is 3G, and there'll be a reaction. There's a 25 Newton force applied to it, and friction, and I'm just going to label friction as mu r because that's the calculation we're going to use. Okay, so first thing I need to work out is what acceleration is that force going to create. So I'm going to use F equals ma, and my arrow is a little bit clearer, but that box is going to be moving to the right, so I'm going to use right as my positive direction. So the total force to the right is the 25 newtons minus mu r, and that's going to equal the mass, which I know is 3 kilograms, times acceleration. And going back to my force diagram, because there's no other forces going up or down, reaction is 3G. Okay, the 25 newtons and the friction won't affect that because they're perpendicular. So, and I was also told in the question that mu was 0.6. So I've got everything I need. 25 minus mu times r is 3a. So if I put the left-hand side of the calculator, 25 minus 0.6 times 3 times 9.8 is 7.36, which is 3a. So a is 2.45 meters per second squared. Okay, so what the question actually wants. So the question wanted the speed of the box when the force is removed. So I'm told that it starts at rest, so the initial velocity was 0. I'm told that this force is applied for 8 seconds, and I've just worked out the acceleration, so I will be able to use that because I've got 3 bits of information. I've got u is 0, t is 8, and the acceleration I've just worked out, so I will be able to find that velocity. So I'm going to use v equals u plus at, so v equals u plus at, so 2.45 times 8 gives me a final velocity of 19.6 meters per second. Okay, so there's my answer to part A. Right, and part B, the length of time it takes the box to come to the rest from the instant the force is removed. Okay, so when the force is removed, okay, so because obviously acceleration is going to change. So when the force is removed, it's still going to be moving in that direction. So friction will still be working against it. R is not going to change, so the weight is still 3G, R is still 3G. So I'm going to still take to the right as positive. Okay, if you can see my screen, right, so that's what I've just been sketching. So there's my new diagram. The only force is friction slowing that object down. So I'm going to, I'm going to take left as positive. So the resultant force to the left is mu r, that's the only force, and that equals the mass, which is 3 times the acceleration. Mu is still 0.6, r is still 3g. So a is going to be, well, basically those 3's cancel, don't they? So a will be 0.6 times g, so 5.88 meters per second squared. And it's vital that I acknowledge that that's to the left, because now I am going to take right as positive when I use that. So it was, when at the point the force is removed, we've worked out here that it was travelling with a velocity of 19.6. So that becomes my initial velocity for when the force is removed. I'm going to get, I've got an acceleration, and because I'm taking right as positive, that acceleration is minus 5.88, and that makes sense because it's going to be slowing down due to the friction. Is it the time I'm trying to find? Yeah, I'm trying to find the length of time it takes. Like that screen. Okay, so I'm trying to find t. And is it until it comes to rest? Yes, so in the question right, until it comes to rest. So it's going to come to rest when v is 0. So I'm going to use v equals u plus at. So 0 equals 19.6 plus minus 5.88t. So t is going to be 19.6 divided by 5.88. So 3.33 seconds.